section 11.1, our objective today is I can determine whether a sequence is arithmetic, geometric, or neither. So we're going to start out with a few definitions. A sequence is a function whose domain consists of positive or consecutive positive integers. In other words, it's just a list of numbers, of positive numbers. A finite sequence is a sequence with a limited number of terms. So for example, 3, 7, 11, and 15 is a finite sequence because 15 is the last number in the sequence. An infinite sequence has an unlimited number of terms. So the example here is 3, 7, 11, 15, and then you see these 3 dots. That means that the pattern continues forever and ever into infinity. So it is an infinite sequence because it has no stopping point. Now we have two specific types of sequences that we want to talk about. The first one is an arithmetic sequence, or in some books it's called an arithmetic progression. And that is a sequence in which the difference between any two consecutive terms is a constant called the common difference. Okay? And the symbol we use for common difference is a D. So for example, 3, 7, 11, 15, and 19 all have a common difference of 4. Because 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19, and when we know the common difference, then we can find additional terms. So because I know the common difference is 4, I know that the next number in the sequence must be 23, and then the one after that must be 27, etc. Okay, so the common difference allows me to build the sequence. Okay. So in this case, it's an arithmetic sequence with a common difference of 4. So the thing that tells you it's an arithmetic is that when you take, if this is term 1, term 2, 3, 4, 5, when you take term 2 minus term 1, you get a 4. When you take term 3 minus term 2, you get a 4 again. And so that is a constant that you find throughout the whole sequence. So that tells you it's arithmetic. The second type of sequence is what we call a geometric sequence. And a geometric sequence is one in which the ratio of every pair of terms is a constant called the common ratio. And the symbol we use for common ratio is R. So, for example, in this sequence, 2 is my first term, 6 is my second, 18 is my third, 54 is my fourth term. And if I take term 2 divided by term 1, 6 divided by 2, I get 3. If I do the same thing with term 3 and term 2, I get 18 divided by 6, I get 3 again. 54 divided by 18 is 3 again. So 3 is the common ratio. And so I can build the sequence because I know the common ratio. I just take the previous number and multiply it times 3. So 2 times 3 gives me 6, 6 times 3 gives me 18, 18 times 3 gives me 54, and if I wanted the next term, I would just multiply by 3. So we use the common difference and the common ratio to determine what kind of sequence we're dealing with, and also to find additional terms in the sequence. So example, find the common difference and the next two terms. Okay? So because I'm asking you to find the common difference, I'm automatically telling you it's an arithmetic sequence. So example 1. I have 5, 8, 11, 14, and 17. Okay? And so I told you it's arithmetic. So first thing I want to do is find the common difference. So I take 8 minus 5, that gives me 3. And 11 minus 8 also gives me 3. 14 minus 11 also gives me 3. And 17 minus 14 gives me 3. So the common difference is 3. And so to find the next two terms, I just add 3. So 17 plus 3 is 20, and 20 plus 3 gives me 23. So 20 and 23 are the next two terms in the sequence. Example 2. If I have 23, 16, 19, 2, and negative 5, okay, notice that my numbers are decreasing. So we would expect the common difference to be a negative number. Okay? So if I take 16 and subtract 23, that gives me a negative 7. If I take 9 minus 16, again it's a negative 7. If I take 2 minus 9, I get a negative 7. And if I take negative 5 minus 2, I get negative 7. So the common difference equals negative 7. So therefore, to find the next two terms, I just subtract 7 from negative 5, or I add negative 7 to negative 5, which gives me negative 12. And then I add negative 7 to negative 12, which gives me negative 19. Okay? So, next example. For each geometric sequence, find the common ratio. Right, so I'm telling you it's geometric. So we know that it's going to have a common ratio. And then I'd like you to find the next two terms. Okay, so number 1, I have 3, 6, 12, 24. Okay, so if I take 6 and divide it by 3, that gives me 2. And if I take 12 and divide it by 6, that also gives me 2. 24 divided by 12 is 2. So the common ratio equals 2. So that means to get the next two terms in the sequence, all I do is multiply by 2. So that 24 times 2 is 48. And 48 times 2 is 96. Okay, next one. We have 90, negative 30, 10, negative 10 thirds. Okay, so first of all, find the common ratio. Negative 30 divided by 90 gives me 1/3. 10 divided by negative 30, I'm sorry, that should be a negative 1/3, gives me a negative 1/3. And negative 10 thirds divided by 10 also gives me a negative 1/3. So the common ratio equals negative 1/3. So to find the next one, I multiply negative 10 thirds times negative 1/3, which gives me a positive 10 ninths. Then I multiply that by negative 1/3, which gives me a negative 10 over 27. So those are the next two terms in the sequence. Okay. Now, we also have rules. Because it's function, sequences are functions, we have rules that build the function. So, example, given the formula for the nth term, find T1, T2, T3, and T4. In other words, find the first 4 terms in the sequence. Then tell if the sequence is arithmetic, geometric, or neither. Okay, so the rule is T sub n, in other words, each term is in the sequence is found by taking 3 plus 2 times n, where n is the term or the number of the term. So in other words, T sub 1 is the first term. So 3 plus 2 times 1 is 5. So this is the first term in the sequence. T sub 2 is 3 plus 2 times 2. So that's 4 plus 3, or 7. So that's the second term. So then we get 2 times, or 3 plus 2 times 3, which is going to give us 9. So that's the third term. And T4 is 3 plus 2 times 4. So 2 times 4 is 8. 8 plus 3 is 11. So that's the fourth term. Right, and so now we have 5, 7, 9, and 11. So 7 minus 5 gives us 2. 9 minus 7 gives us 2. 11 minus 9 gives us 2. So this is a common difference. So that means it's arithmetic. So the fact that it has a common difference tells us that it's arithmetic. Example 2. The rule is T sub n is equal to the square root of n. So T1 equals the square root of 1, or 1. T2 equals the square root of 2, which is just square root 2. T3 equals the square root of 3. And T4 equals the square root of 4, which is 2. Okay, now we look to see, is it a geometric, arithmetic, or neither? Well, you can see, well, here's our ordered sequence in order. And you can see that square root 2 minus 1 is not the same thing as square root 3 minus 2, which is not the same thing as square root 3, not the same thing as 2 minus square root 3. Okay, so it's definitely not arithmetic. So then we try, is square root 2 divided by 1 the same thing as square root 3 divided by square root 2? And then 2 divided by square root 3. So this is no for arithmetic. It's no for geometric. And since neither one of those, since we don't have a common difference and we don't have a common ratio, then we say this one is neither. And the last one is T sub n is equal to negative 2 times 3 to the n. Okay, so that means T1 is negative 2 times 3 to the 1. T2 is negative 2 times 3 to the 2. T3 is negative 2 times 3 to the 3. And T4 is negative 2 times 3 to the 4th. So this is 3 times negative 2, which is negative 6. This is 9 times 2, which is negative 18. This is 27 times negative 2, which is negative 54. And then we have 3 to the 4th, which is, oops, I transposed those there. I'm sorry, it's 3 to the 4th, okay, which gives us negative 162, okay? And so we get negative 6, negative 18, negative 54, and negative 162 are the first 4 terms. And so if we take negative 18 and subtract negative 6, that gives us a negative 12. And if we take negative 54 and subtract negative 18, that is not going to equal negative 12. So it's not arithmetic. So then we take negative 18 divided by negative 6. That gives us a positive 3. So is negative 54 divided by negative 18 also a 3? And yes, it is. And just to double check, make sure, do the last one, that's 3, so we have a common ratio. So this one is geometric sequence, okay?